Hey, we're back with part two of the flower unrolling, unfurling series here. This one is going to be, excuse me, I'm going to be showing you guys how to make this like unrolling carpet of plants, or it doesn't have to be plants, it can be whatever you want. But it's really, really easy. It's using the same principles that we used before. We're going to be using Simple Tree. So if you don't have Simple Tree, it's going to be a little hard to follow along. But Simple Tree makes it super easy. So you guys are going to be so surprised at how easy this is because it looks really complex, and technically under the hood it is, but if you get this Simple Tree plugin, it makes it so easy. So let's get started here. So let's jump in, put down a draw curve, and then I want to go into my front view here, and let's just make something like, I don't know, let me just draw like from here, kind of draw down, go all the way out. Doesn't need to be perfect, something like that. Cool. All right, and then let's resample it. Resample, come on. Okay, and then let's just kind of make it kind of coarse like that, and then do another resample. And this time we're going to go subdivision curves, and there you go. Now it's nice and smooth. Okay, now we can go back to our normal thing here. Cool. And then what I want to do is I want to put this into a copy and transform. Copy, transform. And I'm going to right click on the total number and go copy parameter. And then in rotate under the Y, I'm going to go 0 divided by paste relative references. Wait, no, that's not what I want. I'm an idiot. Delete this. So I want to do 360 divided by, and then paste relative references. So now whenever I change this up here, it automatically rotates everything 360. Okay, let's do something like, I don't know, 16 seems fine. Great. And then all we need to do is do STT initialize curves again, which gives us this. And let me turn off this visualize width. And then remember, if you remember from the previous tutorial, this basically takes any input curve and then allows you to use it in Simple Tree, which is great. And let's do a simple grow. And then there we go. Boom. Okay. Easy as that. So let's play around with this a little bit. I want the growth blending to be maybe more like this so that it kind of comes out. And then I don't want it to be so uniform. I want these to kind of be a little staggered. So let's try adjusting the growth. Let's do random per branch, or maybe noise would be good. And we can do kind of adjust the element size here. So now if we maybe blend it a little more like this. So really, like, there's just, that's maybe way too much. Let's try something like this, bring this back down. Yeah, something like that's kind of cool. Cool. Okay, and then unfolding. The unfolding amount, maybe I change this to like 360, something like that. And then I can adjust the up vector too. I could do noise again. So I can blend this, bring the noise down, blend this more. So what does that look like? So just basically trying to make it look really weird. Okay, so play around with those. You can make it look as nice and even as you want, or as messy and organic as you want, just kind of by playing with these little sliders. You can try adjusting, do like random per branch, something like that. So that way it kind of just comes out really weird. Okay, so now that you have that, what we're gonna do is put this into a skin, which basically creates geometry based on curves. And I want to use the VWrap on so that it does that thing there. And then you can see we've now got this like unrolling mat, which we're going to stick a bunch of instances to. So if you followed me in tutorials before or in the future, basically my favorite thing to do is animate some weird geometry and then stick a bunch of instances to it. And then it looks like a really weird particle simulation, but it's really just geo animated with instances on it. It's super simple. Okay, so how do we do that? How do we get them to stick? So first we want to put down a scatter here, and let's relax the iterations, or turn off relax iterations, excuse me. Put down 10,000 of these, maybe 30,000, okay? And then, get out of here. What I want to do is go into the output attributes and make sure I check on the prim_num attribute and prim_uv attribute. Oh, and then one last thing, we need a time shift. So let me find a nice frame here, or first let me just keyframe this. So let's start from like here, and we'll go frame 0, put that there, and then we'll go to like frame 120 and go all the way out to like that. Okay, and let's just make it linear for now. Cool. So what I want to do, I want to time shift this. So just make sure at frame 120. So this is where they're going to be held. So now if I move it back and forth, they don't move. That's what we need. Okay, then we need an attribute interpolate. Put that down and put this here and that there. And I can never remember which one goes in the other one. So I think these need to be reversed. So if you hit Shift R, it reverses the little wires. So yeah, Shift R. So now nothing happens. Why? There, okay. So now you can see the points are sticking and they're not moving around. Okay, let's make sure this has normals. So let's turn on our normal. It does not. So let's put down a normal node up here. Now let's see. Now, kind of. It does have the normals, but I don't think they're doing what I want. They're all sort of facing downwards. I want them to make sure that they roll outwards with this geo. So I think what I need to do in the attribute interpolate, make sure I interpolate vertex attributes too. There, that did it. So now you can see the normals are facing, they're kind of moving along with this. It's important to have your normals do that because then the flowers or the geo or whatever you stick to that is going to align to that little line you see there. Okay, cool. So we've got that. What else can we do here? Let's, under the Skinner, we could maybe, let's see, maybe I do quadrilaterals. What does triangles look like? Is that a little better? No, quadrilaterals might be better. I wonder if I subdivide this, if this will help. It's kind of nicer. I'm trying to get rid of some of those angular things there. And you can always come back up here if this mesh is too coarse for you. You can come to this copy numbers and you can increase this to like 30. That'll give you more. Let's go like 60. Subdivide. So now it gives us like a really detailed crumpled edge here. So cool. That's looking nice. Okay, so how do we stick stuff to it? Well, you've probably done this before a million times. There's a few ways we can do it. You can use a copy to points. You can use a mops instancer. I like to use the mops instancer over the copy to points just because it's easy. And by the way, if you don't have mops, it's free. I mean, some of the stuff you have to pay for, like some of the more advanced stuff, but the mops instancer, which is basically a much better version of the copy to points, is free. So get it. Let's put a null here. We'll call this out points. But if you end up using like thousands and thousands and thousands of these things, you may want to use Redshift instances because it'll run a lot faster or render a lot faster. For now, I'm just going to use a mops instancer just to kind of see what we're doing. And then if we need to later, we can use a Redshift thing. So I've prepared a few models here, these grass models. So let's grab that and let's just object merge. Put that here. Over here, change this to grass 2. Copy it, change it to grass 3. Copy it, change it to grass 4. Okay. Another thing I need is p-scale here. So let's put down a attribute randomize. Let's put down p-scale and change this to 1-dimensional. And then under options, make sure the seed attribute is ID. I don't think we have an ID. I guess we could just use ptnum. That should be okay. And then let's visualize this. Let me just change this to like 0.01. So if we go to this little box thing, click and hold and come down to lit spheres, you can now see the p-scale, which is great. I love that feature. So let's go 0.01, and then let's make the top one like 0.4. Whoop, that's way too huge. 0.2, something like that. And we can change this instead of uniform. Let's do like custom ramp. Make this 0.2, make this 0.1, make this one 0.01, and then let's move this way up here. Maybe even delete this guy. 0.01 maybe should be our top, and we'll make this 0.05, something like that. So we can kind of play around with the sizes here. Okay, cool. And then let's see, these should not be changing size as they move. Great. Okay, the other thing I want this to do is I want the flowers at the edges to have a p-scale of 0, and then as they roll out, I want them to scale up. So how do we do that? Well, the nice thing about using simple grow is it gives you this attribute called grow, which if we visualize it, if we come up here and visualize grow, you can see that the tips are a different color than the ends, which basically, and if you see this little graph here, you can see they go from basically like 0.5 or 0 to 1. So we can just use that as a p-scale. We just have to make sure that we have that attribute, that it gets passed on to the skin. And I believe it does. Looks like it. Okay, looks like it's getting passed on. Let's see, p-scale, do we still have it here? Grow, we still have the grow attribute. We do, great. So I think what I'd like to do is now we can use a wrangle here. Don't worry, this is very easy. So we've already got our p-scale attribute. All I want to do is say at p-scale times equals at grow. And that should do it. Maybe I need to remap my grow a little bit here. So let's go first up here. We'll go float grow equals channel ramp grow, and it's based on the grow attribute. No, that's not what I want to do. I want to do a point vop. And let's turn off the visualizing that thing here. What I want to do is make sure I'm visualizing my grow attribute here. Grow. Okay, and now let's bind. So let's bring in our grow attribute. Grow. And then we're going to bind export. Also grow. And then we want to use a ramp parameter. We want a range, a fit range. So we know it goes from 0 to 1. Is this what I want to do? Okay, so that does something. Actually, you know what? I think I did want a ramp. I think I was right the first time. Let's change this to, damn it, spline ramp. There we go. Then we need to go up, and we need to make one side larger, and now it brings us back to what we had before. But if I move this, I think I have some control over. So let's try this here. Let's get rid of this. Let's revisualize our lit spheres. They're so lit. Strange. Okay, so my problem was that I accidentally deleted my attribute randomize that had the initial p-scale value, so everything was going crazy. So I re-put that back there, and now we're back to where we were. If we go to this point VOP now, we have this ramp that we're using to control the size. So we can kind of move this back a little bit more so that the ones at the edges are really small or non-existent. See that? So now they basically will shrink down to nothing and then scale up as they kind of lay down flat. And I probably want them more like this. And I think I want this to be, I like monotone cubic, something like that. And maybe bring this here, something like that. Let's see what that looks like. So that's a little better. Cool. So the other cool thing is now we have this grow attribute, which has a different value at the tip than it does at the base. So we can use that in Redshift to color our plants and make them, the tips be a different color than the base of it. But that's pretty much it for this, how the effect is. Now all we need to do is copy stuff to it. So we've got, let's turn off back to points. We've got our attribute thing here. So I think I'm going to try this right now first with these guys, or with a mops instancer. So let's put this into the mops instancer. And I think, let's see. First, I know that this model is like gigantic. So let's go to global transform and bring these like way down, like 0.01. Okay. Cool. And then under distribution, instead of a grid, I want it to be a mesh. And the mesh I want is the points. And then the distribution should be points. There. So now we have it. And it's still like, these are huge. So let's maybe go like 0.005. 0.001, something like that. And I don't think they're aligned properly because I think my model is not aligned correctly. So let me come up, go to my models. You have to make sure they're facing in the Z direction. So let's just transform this. We want them to be facing, where's the Z? In the positive Z direction, I believe, like this. Okay, let me just go back to my other model, paste that, paste it, paste it, paste it. There we go. Okay, and now if I come back here, they should be aligned in the proper direction. Yes, they are. So if I hit play, right? Well, it doesn't matter right now because I'm going to randomize the hell out of this anyway. So what I can do is do a mops randomize. Again, another free mops tool. Definitely recommend it. So let's do randomize orientation. Okay, so now they're all facing in different directions. And then let's do, you can also randomize p-scale if you want. We've already got it randomized over here. But you could randomize the p-scale, you could randomize color, stuff like that. So let's maybe increase the p-scale here a little bit so I can see these. Let's do 0.01. 0.2 on this one. Maybe do 0.01. Is that doing anything? Doesn't seem to be doing anything. I'm wondering why. Nothing? Strange. Well, I'm wondering if it's because I'm using a MOPS instance, or I wonder if I did a copy to points. And let's just do pack an instance. Target points to copy to is this. Target, let's just try one of these guys. Okay, I figured it out. I forgot in the MOPS instancer, it doesn't read the p scale and stuff until you go over under distribution. You have to do enable template interpretation and enable scale attributes. Now it's going to read our p scale that we've defined. So let's bring this, I put this way up just for 0.02. Let's try 0.1, 0.5, 0.3. Okay, and then this one should be, let's try 0.2, and this can be 0.1, something like that. Cool, get rid of this copy to points. I don't need this anymore. So basically that is how you do it. And these are all randomized. Let me try orientation. Is this, let's do 1080, 1080, 1080. I want these to be completely randomized. Oops. 1080 minus 1080 minus 1080. Like I just want so many of them that you can't even tell where they're going, which direction they're going. So I probably want more points than this, actually. I probably want a lot more. But you can see they're unrolling. So if I play this, so this is kind of the benefit of doing it this way with the MOPS instancer or copy to points or whatever, is that you can kind of see the actual geo. If you were to do it with Redshift instances, you can't really see the geo as well, but it moves a lot faster. But let me show you how to set it up with Redshift instances, just in case you want to know. I'm sure I've showed this a billion times in other tutorials, but also all you need to do is do attrib create on your points. Come here. And what it's going to be is instance, which is a point attribute. It is a string. And then the string you need is your model, just any model. So copy the path, paste it there. And then to randomize it, you do attrib randomize. And instead of CD, it should be instance. And we want to make sure that you use a seed attribute, either ID. If you have a consistent point count, like we do in here, you can use ptnum, but if you're using like a simulation or something, you always want to make sure you check the seed attribute on. Otherwise, it's going to like change the randomization seed every frame. Okay, and then under distribution, let's do custom discrete, and then type is string. So we can just paste that path here again, and if you have more than one model, you can just change the path. Oops, I want it to be grass 3, grass 4. There you go. Okay, and then what you want to do is copy this final output path thing here, and then put down an instance node, delete the add that comes with it, and put down an object merge. Paste that in there so you got your points again. And then make sure you've got instancing. You can put it to Redshift instances or Redshift point clouds. I'm not really sure what the difference is, but for whatever reason, Redshift point clouds tends to work better for me. And then let's just check to see if this is working. So one thing you can do under this instance node, if you go to point instancing, you can change this to full point instancing, and then you can see it, which is nice. And then what is fast point instancing? No idea. Is there a difference? It runs pretty fast, actually. It's kind of nice. Let's do full point instancing. It doesn't seem like it's respecting the p-scale, though. I don't know if this is just the display or not, but let's just set up a camera. Let me go into it, kind of move it so I can see. Ugh, get me out of here. Somewhere, God, why is this not working? Let's just set up something like this. Let's throw down a sunlight, and then let's just fire up the render view and see if what the render view gives us matches. So it does. You can see it looks just like this, which is not how I want it to look. I wanted it to look like the other way. So why is it not respecting my p-scale? Well, maybe it is, and I'm just not. Maybe I need to. What if I bring this down to like 0.01? Does that do anything? 0.02. Refresh. Huh. Doesn't seem to be 0.03. Nothing. Interesting. I think it's, was it this? Ignore pivot point attribute? There was something, was that it? Okay, so I figured it out. I forgot that when you use Simple Tree, it comes with a bunch of attributes, like all these like transform and local transform and all stroke direction, stroke hit. I think the transform attribute and the local transform attribute, they kind of mess with the p-scale and they override it. So what I did is I put down an attribute delete, and I basically just kept grow, instance p, and p-scale, and I hit delete non-selected, and then it suddenly respected my p-scale. So, and then I put down an attribute adjust float, and I just multiplied my p-scale by 20, so it scaled up uniformly a little bit. Now, the other thing we want is we want an attribute randomize. Come on, attrib. God damn it! Why can I never type this? Okay, and what I want to randomize is orient. It's a 4 thing, and let's do inside sphere, and let's put this down, and that should. There we go. Much more natural looking. So just completely scramble up all the orientation there. So that's looking a lot better. That's like, oh, and then make sure options, seed attribute, PT num. Okay, so that is so much better. So that is basically it. The other thing we can do is just to show you, I think I've showed this before, but if you go to your material context, and I've already got my material set up obviously here, you can bring in that grow attribute. So let's do rs point attribute and change this to grow. And then let's just put this in the base color and see what that does. If I put a ramp in it, let's just solo this. Cool. So you can kind of see what we can do there. And maybe what I need to do is back here, I want this in the geo. Let's put down, let's grab our point VOP here where we used to adjust our grow attribute. Let's put this here. Let's get rid of this ramp. Let's put down a range mapper, or sorry, range, fit range. There we go. And then in the fit range, let's adjust this and see if this does anything. Let's put this to -1. Let's see, maybe I need to, basically I'm trying to get it so that this black part kind of moves back a little bit so it's not quite so abrupt. Let's put this to 2. 1.5. Let's go back to my material. And let's bring this back. Just bring this to like this, and then let's go to this guy here. 1 minus 0.5. Let's see what that does. I don't know, maybe I just need to play with these a little bit. That's better. Okay, let's go -5. Okay, so it's this one you need to do, the destination, not the source. Because the source is already to 0 to 1. Let's go -20. Let's just like really crank this. That's doing more like it. -40. -80. Okay. -160. Just, dang, really got to do this. -300. Okay, so I played around with it a little bit. I found a value of -50, kind of gives me what I want. So if I move ahead, you can see the tips are going to be a different color. It's sort of this fringe. Cool, so let's go there. And let's go back to our material. And I can unsolo this now. And what I want is to, let's do like a color composite. And let's put our original albedo texture or diffuse material or whatever into the base color. And then let's, sorry, not a color composite, color, damn it, color mix. Like this, and then I can do a color correct. Put that, come on, give it, put it in there, put this into input 2, change the hue a little bit, and then we'll use our grow thingy as a mask. And I think I want this, let's switch these inputs here so that this one's in input 2. So yeah, so now the tips are going to be whatever color I choose. I can make it more saturated to make it, you know, crazier or whatever. So that's basically what you do. It's super easy. There was a couple little hiccups there with the kind of the P scale and stuff like that, but this is how I made that video that I showed you. Yeah, it's pretty cool. You can use it. It doesn't have to be plants. It can be any lines, any geometry. I'm going to show you in the next tutorial a few different tricks on how you can like slice up pre-existing geometry into lines and use it, make things unfurl like that. But yeah, so all I would do now is just, you know, find a nice angle, maybe build an environment around it. But let's get in here, something like this. Maybe turn on our DOF. I like to do under redshift camera, under optical. I pretty much always use this filmic and then just kind of adjust the exposure down a bit. Let's turn on bokeh, enable legacy, click this off, and then let's bring this down to like that and click our finder, like that, and bring this down. So you can see, this is basically all I did. It's super fun. It's super easy. I highly, 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 highly recommend that you guys get Simple Tree. It's one of the plugins that I just cannot live without. I mean, you can totally do this stuff yourself manually, but it requires a lot of code. you really need to know a lot about like quaternions and matrix transforms and stuff, which I don't. And I don't care to right now because there's a tool that exists that shows me that just does what I want. It's great. So I hope you guys found this helpful. Let me know if you guys have any questions. Otherwise, I will be creating the next in the series soon and show you guys how to use and some other really fun and interesting ways that you can use this. Cool. Thanks.